Good morning. Today's lesson, we continue to learn about probability. In the last lesson, we looked at a probability scale, which you can see on your screen now, which is used to help us to describe the chance of something, an event, occurring. We looked at how likelihood uses words to help us, such as it's unlikely or it's certain. And then we learnt that probability is putting a numerical measurement of that chance. So our answers do not include words. Instead, we would say there is 100% chance rather than the word it's certain. Now, the problem is that it's difficult to know which number to use at certain times. For example, if you remember with the likelihood scale that the word unlikely represented everything from just above impossible, which if you look for our numerical measurements for probability means just above zero, and was the entire section then until just before the even chance likelihood, which is the probability of either a half as a fraction, 0.5 as a decimal, or 50% as a percentage. So the entire range here was used if something was felt to be unlikely. Now, sometimes having such a big difference can really cause problems. And in mathematics, we like to be accurate. If I was to ask all of you now to put a numerical measurement, so what do you think the probability is of it raining tomorrow? Then you might all give me different answers. You may decide that, well, that's pretty likely in terms of likelihood and words, but for a number then, that could be anything from above even chance of likelihood, so above a half and less than number 1 or 100% less than certain. So you may have picked something like 0.8, someone else 0.6, or maybe somebody has seen the forecast and it has said that it's not going to rain and therefore they might pick something down here. Now remember that you cannot choose 0, 0.5 or half or 50%, or 1 or 100%, unless you are absolutely sure that that's exactly the correct location. So we wouldn't be able to pick those three because it's definitely not certain, it's definitely not impossible, and there are more options of weather, so we can't say that it is exactly a 50% chance either. So which one of us is right? Is it 0.6 or is it 0.8? Well, thankfully, there is a way of us finding the exact measure of probability. And that's what we're going to be looking at today. And it's called theoretical probability. And there is a formula to help us to find the exact probability measurement for each event. And that's this. So, to find the probability of an event. Now, we know that in mathematics, we much prefer to use numbers or abbreviations or symbols rather than writing lots of words. So if we want to work out the probability of something, we can use then a capital P. And then immediately after that P, we have a bracket. And inside that bracket, we would write what event that we are trying to calculate the probability of. So, for example, if I wanted to work out the probability of flipping a coin and getting a head, then I would put the letter H inside my bracket or the word heads. And that means I want to find the probability of getting a heads. Now, you'll notice that the actual answer then is a fraction format. We have something on top of another something with this line in between, which means it's going to end up as a fraction. And we know that that is absolutely correct as one of the methods that we can show probability. either as a fraction, as a decimal, or a percentage. So let's see, what are those numbers meant to be on the top and the bottom? Well, if we look on the top here, it's the number of desirable outcomes. So on the top, we write down how many there are of what we're finding the probability of. And then on the bottom, you write down how many possible outcomes there are, the total number. And we've done quite a bit of that so far this week when we were looking at sample spaces. So if I was to apply our formula to our example of flipping a coin, so if I want to find the probability of flipping a coin and getting heads, well, that's a lot of writing. I prefer to leave the words for the English teachers. So instead, I'm going to use a capital P to show that I'm calculating the probability of, and then what we're calculating the probability of goes inside the bracket. So I could write the name heads, as I said before, or simply use a capital H. Now, as we just discussed, our answer is going to be a fraction, so I have my line here ready. Now, what goes on the top then is the number of desired outcomes. Well, what we desire is what we want. So it's asking us, how many are there of what we want? And we want a heads. So on my coin, how many of all the possible outcomes were heads? Well, there was just one. There's one head on a coin. And then the number that goes on the bottom of the fraction is the number of total outcomes. So if I flip a coin, how many possible outcomes were there in total? Remember, outcomes means results. Well, there was either heads or tails. So there's just 2 outcomes. And there we have it. The probability of getting a heads is 1/2. Or we can turn that into a percentage, 50%, or a decimal, 0.5. Okay, so let's test this out on something else, on a different event. What about our die? What if I'm interested in finding the probability of rolling the die and it landing on a 6? Okay, so let's make sure that we use correct notation. We need a capital P to show that we are doing probability. We're calculating probability, and then a bracket, and inside the bracket we're putting the event that we are actually measuring the probability of. Okay, so I want to find the probability of getting a 6 when I roll a die. Well, we know that that is equal to, first of all, how many of the desired outcomes are there? So in other words, on a die, how many 6s are there? Well, there's just 1. And then on the bottom of our fraction is how many possible outcomes are there in total? Well, we know that there's the number 1, 2, 3, 4, 5, and 6. There are 6 total outcomes. So the probability of rolling a die and getting the number 6 is 1/6. Your first letter to record down is W. Here I have a spinner. And on my spinner, there are 1, 2, 3, 4, 5 different sectors. A sector is the name for one of these pieces of this circle, a little bit like a piece of cake or a piece of pizza. So there are 5 sectors of different colours. Now, I can calculate the probability then of getting any one of those colours. So let's work out what's the probability of getting a yellow. So in my answer to a question in an exam, I would write capital P, brackets, and then what it is I'm measuring the probability for, well, of getting a yellow. You could have perhaps chosen to put a capital Y. As long as the examiner is clear that what you put in here and what is we're actually measuring the probability for then that's absolutely fine. So if Y is obvious that it's yellow, there isn't another colour that begins that same letter, then you can pick the letter Y. Now, we know that probability is a fraction to start with. We can change it to a decimal afterwards or a percentage if we wanted to. But we're going to start off with the fraction. So the top number, if you remember, is the number of desired outcomes. So on my spinner, how many are yellow? That's my desired outcome, what I'm interested in working the probability of getting a yellow. Well, there is just one yellow. And then out of how many outcomes are there in total? And we said that there are five sectors. So my probability of getting a yellow is 1/5. Now, don't forget that we can convert that if we wanted to a decimal or to a percentage. For a decimal, just to recap, we can change a fraction to a decimal by simply remembering a fraction is a division, 1 divided by 5. And we can turn a fraction to a percentage by simply multiplying by 100. Your second letter to record down is P. So we could say that the probability of getting a yellow from this spinner is either 1/5, or we could say it's 0.2, or it's 20%. If I was to describe it then in likelihood terms using words, can you remember which word we would use for 0.2, 20% on the likelihood scale? It's unlikely. It's bigger than 0, but less than 0.5. So, yeah, what's the chances of us getting a yellow? It's unlikely because of all the other colours. But the probability of getting a yellow is an accurate numerical measurement, and we know that that is 1/5. Remember that you don't have to write all three ways, the fraction, the decimal, and the percentage, unless you are asked. But if a question asks you for one particular way of writing your answer, then you must make sure that you do so. In this example, I have another spinner, and this time the spinner could land, once it's spun, on either the numbers 1, 2, 3, 4, 5, or 6. Now I'm interested this time in working out what the probability is that the number that we land on will be prime. So my answer in my exam will have capital P to show I know I'm working out the probability. I have a bracket and what I am calculating the probability of inside the bracket. And I know that my answer then is how many there are of what we're interested in. So how many of these numbers on my spinner are prime? Well, remember, prime numbers have exactly and only 2 factors. And therefore, the only numbers on here that can be divisible by themselves and 1 and nothing else is the number 2, 3, and 5. 1 has only 1 factor, that's not prime. 4 can be divided by 2, and 6 can also be divided by 2 and 3. So 2, 3, and 5 are prime. That means we have 3 prime numbers. So there are 3 of what we are interested in, 3 prime numbers. And how many outcomes are there in total goes on the bottom. And there are 6 numbers, 6 outcomes. And there we have it, 3/6. However, if you remember from when we learnt about fractions, we must always cancel them down. If there's a number that I can divide the top and the bottom both by, then I must do so. And therefore we can see that 3 and 6 can both be divided by 3. And we end up then with the number 1/2. The probability of getting a prime number is a half. And that makes sense. Half of the numbers are prime. Half a prime, half a not, so the probability will be a half, or 0.5, or 50%. A very popular probability question in exam is about marbles or counters or sweets in a bag, and that someone is able to pull out one of those from the bag, and what is the probability of it being a particular colour. So, for example, my bag here, I have both red and yellow counters. So if I wanted to work out what's the probability of me pulling out a red, then we know how to calculate this now. This is how I would write it down. The probability of getting a red is equal to, well, we know that that means how many, what we're interested in. So how many are red, and then over how many there are in total, which will actually be how many counters there are in total. So let's have a look at our bag, and we're going to have to count them out. So in red, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I know that my top number is 10. Now my bottom number is how many counters are there in total. So remember, my total possible outcomes, I could have pulled this one out, this one, this one, this one, this one. So I need to count all of the counters. So I've already got my 10 reds. I can then just go and continue to count the yellows. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 10 out of 20 counters are red. So what does that equal? Would we leave our answer as 10/20ths? We would cancel it down, and that is 1/2. Both the top and the number can be divided by 10. 10 divided by 10 is 1, 20 divided by 10 is 2, or we can simply see that the bottom number is twice as big as the top. Let's go back to the die. What if this time I would like to work out the probability of rolling the die and getting a number that is greater than 4? So if you see in maths notation, capital P for probability, and then inside my bracket for my event, I have the symbol greater than and 4. So the probability of getting greater than 4. Now, be very careful to understand these words correctly. Greater than means it must be bigger. It can't be exactly the same size. So we can't include the number 4. Well, we know that the numbers on a die are 1, 2, 3, 4, 5, and 6. So the only numbers that are greater is a 5 and a 6. So our probability then will be how many are there of what we want, how many are greater than 4, 2, over how many are there in total, and there are 6 numbers on a die, 2/6. We then know to cancel this down, so I can divide the top and bottom both by 2, and our answer is 1/3. Your third letter to record down is T. What is the probability if a bag contains 5 red and 10 blue marbles? One marble is picked randomly from the bag. What is the probability that that marble is blue? So it's important that we would use capital P and the brackets. We can't just write an answer. We can't just put a fraction, a percentage, or a decimal. We need to use notation as well as part of our answer. Well, the probability of getting a blue marble, so we could write a capital P and then blue, is how many there are that we're interested in. So how many are blue? 10. And then the bottom number is how many marbles there are in total. And we know that there were 10 blue and 5 red. So together the 2 makes 15. Now 10/15ths, of course, can be cancelled down to 2/3. A fair 6-sided die is thrown, what is the probability of rolling an even number? So again, we would use capital P and then write the word even inside. We know that there are 3 even numbers, 2, 4 and 6, out of 6 numbers in total on a die, and that cancels down then to 1/2. A card is drawn at random from a standard pack of 52 cards. What is the probability that the card that we draw, so that we pick, is firstly a jack and then second a heart? So let's have a look at this. Okay, so the probability of getting a jack. Well, there are 4 different suits, and that means that there are 4 jacks, as there is a jack for hearts, a jack for spades, a jack for clubs, and a jack for diamonds. So there are 4 of what we're interested in out of the fact that we could pick any of the 52 possible cards. 4/52 can be cancelled down by dividing the top and bottom both by 4 to make 1/13. For B, the probability of getting a heart, well, as you just heard, heart is one of the 4 types of suits. You may therefore be able to go straight to your answer, 1 out of the 4 suits. Alternatively, there are 13 cards that are hearts. There are 13 for each of the suits. The numbers 1, 2, 3 to 10, Jack, Queen and King. 1 also being the ace. And 52 again, the total number. And if we had divided the top and bottom by 13, we would have got a quarter again. Please pause the video and record the formula and our example that I have on your screen now into your notes copy. When we conduct a trial, like flipping a coin, all of the possible probabilities, so the probabilities from all of the possible outcomes, will together add to make one whole. For example, the probability of getting a heads we know was a half, and the probability of getting a tails is also a half. They're the only possible outcomes that we could get when we flip a coin. And together, they add a half plus another half makes one whole, or 100%. Remember that those are the certain probabilities. And this is true for all trials. If we looked at the probability for every outcome and add them all together, they will make one whole, or 100%. And this is a good way to check that we have worked out our probabilities correctly. We can check that out with another trial, like the rolling of our die. We know that there are 6 possible outcomes, and if we look at the probabilities for all 6, the probability of getting a 1 is 1/6. There's 1 out of 6 numbers. All these probabilities add together. So if you think there are 6 lots of 1/6, and 6 lots of, remember, is multiplication. So 6 lots of 1/6, 6 times 1 is 6. 6/6, one whole. So every trial that we make, the individual outcomes probabilities will all add together to make the number 1. Your last letter to record down is Z. So this helps us to understand this statement here, that the probability of an event this time not happening is the same as deducting away from the total number of probabilities, which we know is 1, the probability of it actually happening. Well, we know that something either does or it doesn't, so if we know what the probability of something actually happening is, we can take it away from its total and it will give us what's left, the probability of it not happening then. Let's have a look at that in action. On this spinner, there are 4 sectors, red, yellow, green and blue. What is the probability that we spin the spinner once and we do not get yellow? Well, we know that the probability of not getting an event is the same as 1 take away the probability of getting that event. So 1 take away the probability of us getting a yellow. And the probability of us getting a yellow is there is 1 yellow out of 4. So 1 take away a quarter will tell us the probability of not getting a yellow. And 1 take away a quarter, well, if we change our whole number into quarters, then we can more easily see that if we had 4 to start with and we take one of them away, we get 3/4. The probability of not getting a yellow is 3/4. Now, of course, we could have done this another way. We could have done it using the regular theoretical probability rules, and that the probability of getting not yellow, well, all of the ones that are not yellow is what we're interested in. And there are 1, 2, 3 of the desired outcomes. 3 out of 4 are not yellow. So if we can calculate the event not happening using the regular method, then why would we learn to do it this way? Well, sometimes this is the quicker method if we've already worked out the probability of that event happening. For example, if we remember, we have worked out the probability of selecting a heart if we draw a card from a pack, and we knew that that was a quarter. So I could very quickly work out what the probability of not getting a heart is, because that would be 1 take away the probability of getting the heart. 1 take away 1/4. The probability of not getting a heart is 3/4. For your homework, I would like you to study the worked examples that are on page 133, 8.16. I'd like you to read it, check that you understand, and the following page, 134. Once you finish reading those examples, then you have an exercise to do, and there are 3 questions that I want you to do tonight. I want you to calculate the probabilities of some sweets, number 1. Number 7, some crisps, and you're going to be using a probability scale as well here. And then number 15, which is over the page, and this is looking at some probabilities for some students' results in their subjects at school. I shall see you in the next lesson. And just for fun, why did the plant dislike math? Because it gave him square roots.